let's try an activity I made to help you practice graphing proportional relationships. This unit that we're in now, 8.3, is all about proportional relationships and graphing them to show proportional constants, the slope of the line. Okay, read the directions. It says, I jog at a slow, constant pace of 12 minutes per mile. You will create a graph that shows the proportional relationship of my distance and time while jogging. You also need to label everything on the graph, like the heading, axes labels, units, and scale. Then you can plot points on the graph to show how long it takes me to run 1, 4, and 8 miles. And draw a line showing the linear relationship between my distance traveled and time. Okay, follow these steps here, 1 through 7, to complete the graph, and I'll give you some help. Okay, number 1, use the text tool to write a title on the graph. Title the graph, My Slow Jogging. Okay, this is the text tool right here. So you're going to want to write a title on the graph. Click that text tool. Title the graph, just like I said, My Slow Jogging. If you have another idea for this title, you can change it to what you want, but you have to have a title on your graph. Have to. My Slow Jogging. Okay, good. Number 2, label the horizontal axis, which is the x-axis, time, and specify the units as minutes. Okay, let me help you with this. Maybe it's your first time labeling the axes on a graph. So you're going to label it as time. And when you specify the units, use parentheses. So time in minutes. You can just put min as an abbreviation. So let's go ahead and do that on the axes of the graph. Use the text tool again. Go down here, and this is for the x-axis. So let's label that time, and in parentheses, you can write out the word minutes or just min as an abbreviation. There you go. Number 3, write the scale from 0 to 100 minutes along the x-axis grid lines. Okay, we're going to scale this from 0 to 100 minutes. First of all, how many tick marks are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 right there, but we need to go to 100. 11, 12, 13, 14, 15. There's 15, but we need to go to 100. 16, 17. Oh no, now we need to go to 100. So that means each tick mark is not going to be 1 minute. We need to go out to 100 minutes. Because our scale is going to go from 0 to 100 minutes. So if we have 17 marks, then we need to divide 100 by 17, or maybe 100 by 15, to see how many minutes each one of these grid lines is worth. So just quickly do some math. Take 100, because our scale goes up to 100 minutes. I'll even label that units. 100 minutes divided by, how about divided by 16? Then how many minutes would it be per tick mark? I'm just going to use a calculator. 100 divided by 16 is 6.25. That's a little difficult. I don't want to use decimals. How about 100 divided by 15? That's not easy either. 100 divided by 12 maybe? I want some easy fraction. If we have 15, I'm going to find an easy scale. How about each tick mark is worth, let's do this. Each tick mark is going to be worth 6 minutes. Okay, let's do that. Each tick mark here is going to be worth 6 minutes. So this is going to be 6 minutes, and this is going to be 12 minutes, and this is going to be 13 minutes. 13, what am I doing? I must be getting sleepy. 18 minutes. Okay, we're going to scale our graph this way. So just count by 6s. So at 10, this is 60 minutes. And at 15, this is 90 minutes. So it's not quite 100. 96, but it's so close. There, this is actually going to be 102. So we're making our scale from 0 to 102. And how did I decide to make this scale? Well, the directions told me write the scale from 0 to 100 minutes along the x-axis grid lines. So this needs to go from 0 to 100 minutes. So how much is each one of these points going to be worth? Well, I divided 100 by, first I divided it by 16, and 100 divided by 16 gave me 6.25. But I didn't want to deal with this little 6.25. So I just checked and I thought, okay, let's make each grid line worth 6 minutes, not 6.25. And then we'll actually fit a little more on. Anyway, so here's what we need to do. Let me get rid of all that mark. Ding. Use the text tool. So on the GeoGebra tools here, click this text tool again. Click. Oops, not that one, this one. Here it is, text tool. And then scale it. Remember, this is 0. And this is 6 minutes. So this is going to take a while, but you need this practice so that you really understand how to do the scale on a graph. 6, what's after that? 18 minutes. We're counting by 6s. 24 minutes. 30 minutes. 36 minutes. Count by 6s. 42 minutes. Yeah, this is going to take a minute. 48 minutes. 54 minutes. This is a good chance for me to practice counting by 6s too. 60 minutes. 66 minutes. 72 minutes. Ha, tiring. 78 minutes. 84 minutes. Please tell me if I've made a mistake. I am not even double checking and I'm really tired. 90 minutes. So I want you to catch any mistakes you see. Don't just copy me. Make sure you're following and checking yourself. Otherwise, you're going to have mistakes. Just copying me is a bad idea. And then this is 102 minutes. Did I get that right? Okay. Now, let's go to the next step. The next step says, label the vertical axis, the y-axis, distance, and specify the units as miles. Okay, so here we want distance in miles. I wonder if it'll let me rotate that. Maybe not. I'm just going to check. Is there anything? No? No? What are all these? I hoped I could rotate it, but I don't know how. So anyway, distance, and then I'm going to go down. Use parentheses for the units, miles. Let's see how this looks. I wonder what these different texts are. Can we try them? Whatever, that looks fine. That looks pretty good, actually. Okay, the next step says, number 5, write the scale from 0 to 10 miles along the y-axis grid lines. Okay, so the scale on the y-axis is from 0 to 10 miles. Well, how many tick marks do I even have? How many grid lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, that's perfect. Okay, so each one of these grid squares is going to be a mile. So 1, 2, well, you don't have this little purple pen on your desktop, do you? And even if you did, I wouldn't be able to save it and see it. You need to use the text tool from GeoGebra. Click on the text tool and then label these units. Label this axis, 1 mile, 2 miles. Make sure you realize these are miles. 3 miles. Go ahead and say the units as you do it so that you understand what the numbers mean. 5 miles. 6 miles is barely going to fit. Not bad. 7 miles. 8 miles. 9 miles. And finally, 10 miles. I wish I was going to go jog 10 miles. I don't have the energy anymore. I'm getting old. I'm going to move this just a little. I think I can put this here, and then I can get this 6 to fit a little better. If you have any numbers that are kind of out of place, then fix them, okay? Like my number 24 down here, there's no excuse for that. Fix your numbers. 66 is floating away. It's hard to click exactly where you want them. So go ahead and take a minute and make your axes look good. Okay? Pretend like you're in college now and you're going to turn this into your professor. I had a professor in college. His name was Dr. Rochefort, and he got really mad at us because we had such messy scales on our graphs. He yelled at all the freshman chemical engineers, and I was one of them. And I'll never make that mistake again. And this one here is kind of hard to see. But, okay, whatever. There, I'm going to do that so we can see it. Okay, so we have titled the graph. Let me just circle what we've done here. We've titled the graph. Great. We labeled the x-axis as time, and we specified the units in minutes. We have labeled the y-axis as distance and specified those units as miles. We have written our scale from 0 minutes to 100 minutes, and we have scaled the y-axis as well from 0 miles to 10 miles. This is looking great. Okay, what is the next step? Number 6, plot the points showing the time it takes to run 1, 5, and 8 miles. Okay, we're going to need to do a little math. Remember, I told you I jog 12 minutes per mile. So we need to figure out how much time it takes, so time in T, to jog some distance. I'll call that D. Let's make a little table here to help organize our data. 1 mile, 5 miles, and 8 miles. Okay, so the distance is 1 mile, 5 miles, and 8 miles. And I said I jog 12 minutes per mile. I'm going to write that down here. I'm going to even put the units. 12 minutes per mile. So just draw a line for a proportion and put mile on the bottom. So K is our constant, our proportional constant. And it tells me for every mile it takes 12 minutes. You could also look at it this way. 12 minutes per 1 mile. That ratio stays constant. That proportion stays constant. Okay, now how do we use that? Well, if we multiply by the number of miles, which is our distance, then that is going to equal the amount of time it took to jog that distance. So D here is this distance. Okay, first, D equals 1. What is the time equal to? When distance equals 1, we multiply 1, so 12 times 1 equals 12. The time is 12 minutes. Great. Now let's try the distance of 5 miles. If our distance is 5 miles, then 5 times 12 equals 60 minutes. takes 1 hour for me to jog 5 miles. Not that I do much jogging these days. Time takes 60 minutes. Okay, now if I've gone 8 miles, then how many minutes does it take? So put the constant proportional thing here, 12 minutes per mile times 8 miles means it took me 96 minutes. There, I did math in my head. I'm exhausted. And I'll fill in this table here. So I'm going to plot these data points on my graph. I'll get the point tool here. Oh, there's all these choices. I just want a simple point. Got it. Okay, so the distance, 1 mile takes 12 seconds. So here is miles on the y-axis and 12 seconds. Plot that point. Ding! And it gave me point A, but I don't think that matters. I should delete that later. The next is a distance of 5 miles, takes 60 minutes. So here's 5 miles on my distance and go out to 60 minutes and plot the point. Great. Okay, next, a distance of 8 miles takes 96 minutes. So here is 8 miles. Go out to 96 minutes right there. Fits perfectly. Now, the last instruction, number 7, says, draw a line connecting the points to show their linear relationship between distance and time. Okay, get the line tool. There's all these choices, but you just need a simple line or whatever. Get that line tool. And then you're going to go from, well, you can connect these points. Or you could start from 0, you know, because at time equals 0, you've gone 0 distance. Anyway, I'm just going to go from, oops, I made a mistake. Let me do it again. Oh, no, I got it. From A to C, there. Okay, so there's a line showing my constant jogging speed. Let me explain what I mean, that this line shows my speed. It does. Look at the slope of the line. The slope of the line is, oops, I don't want that one. Oh, what did I do? There we go. The slope of the line says, for every 1 mile, I run 12 minutes. So that's 1 mile per 12 minutes. That's the slope. It's actually the inverse of speed. 1 mile takes me 12 minutes. Now, I said that's the inverse of speed, but I made a mistake. I'm sorry, that is speed. I wrote it this way as the inverse of speed. 12 miles per minute, that is the inverse of speed. It's very helpful to know the units, because then you'll know what it is you're talking about. This is 12 minutes per mile. This is 1 mile takes 12 minutes. Those are the inverse of each other. Okay, good job. I hope that you can graph this equation and follow all of my instructions. Let me show you what I'll be grading you on. I am going to be grading you on having a title, having the y-axis labeled with units specified in parentheses. I will be grading you on labeling the x-axis with units specified in parentheses. And then I will be grading you for having the scale written neatly and correctly along the x-axis and along the y-axis. Finally, I will be grading you to see that you have plotted the points that I've asked for and that they connect in a straight line which passes through the origin. The origin means point 0, 0. That's very important. If your straight line does not pass through the origin, you've made a mistake. How could it not pass through the origin? For example, if your line looks like this, that means at time equals 0, I've already jogged 2 miles? I wish. No, I'm very lazy. That's not possible. So make sure that your line passes through the origin. Okay. You can now get to it before you move on to the next question.